Good morning guys, Anjani Kumar here and dealing instrumentation subject for final year electrical students. In the last class we discussed about passive transducer, right? We started a passive transducer and in that we discussed about what is a resistive transducer, right? And discussed few examples also, like a Wheatstone-Bridge type transducer and a potentiometer type resistive transducer. I just want to brief rewind all the things, right? So we discussed about passive transducer. So what is a passive transducer? I'm rewinding all these things, right? Better to rewind each and every topic once while starting a new session, right? So what is a passive transducer? The passive transducer is a device which require auxiliary external electrical supply for its operation, right? It's require external electrical supply for its operation, right? And one more definition that we discussed, basically that is a theoretical definition, but actually if you want to find out the non-electrical quantity, it can be find out by changing the resistance itself, right? By changing the physical quantities. So what are the physical quantities here? The resistance, inductance, capacitance. These are the physical quantities. By changing the physical quantities, you will find your unknown quantity in terms of electrical quantity, right? That means if you want to find out the non-electrical quantity into electrical quantity by changing the physical components of the system. So here in a passive transducer, what are the physical components? The resistance, inductance, capacitance, right? If you find the non-electrical quantity by changing the resistance, you can call it as a resistive transducer. If you want to find the non-electrical quantity by changing the inductance, we can call it as an inductive transducer, right? If you find the unknown non-electrical quantity by changing the capacitance, then we can call it as a capacitive transducer. Likewise, these transducers are classified, right? And we started a resistive transducer, right? You will tell the definition, right? So definition is nothing but if you find the unknown non-electrical quantity by changing the resistance itself, by measuring the changing resistance, you will get your non-electrical quantity in terms of electrical quantity, right? So that means you know that resistance R is equal to rho L by A, right? If you changing the length is nothing but displacement, you will get the change in resistance now. So that is meant unknown quantity, unknown electrical quantity, which is a displacement, which is converted to electrical quantity. So it can be used for displacement calculations. Got it now? Right. If you change in the resistivity, you can get the change in resistance now. So you can find the resistivity transducers. Right? These are resistivity. If you want to find the resistivity, it's very difficult. You don't have any instrument to find the directly resistivity component. So for this, we require this type of a transducer, right? If you change the cross-sectional area, your resistance also changes, na? So definitely, so you can find your cross-sectional area. So whatever this area measurement transducer, right? These are the different types of transducer you'll get in resistance by changing the resistance. And we discussed about a potentiometer type resistive transducer. Like how it will work means, how it will work means, this is a resistance, right? This is a slide wire, right? And you are moving. So this is the total resistance. This is the resistance R1, and the voltage across this one. You are assuming that if you put voltmeter across this resistance, you will get 10 volts, right? Your sliding contact is here. Now the displacement is 0. You are moving the sliding contacts here. That means you want to find out the displacement, change in displacement. So you don't have any methods, direct methods. By changing, if you move these slide contacts here, the resistance will change now. Right? So if you find the change in resistance with the voltmeter across, for suppose this is a 5 volts. If 5 volts allow chindi by changing your displacement. So whatever my displacement, which is a non-electrical quantity, which is equal to 5 volts now. So you are converting your non-electrical quantity into electrical quantity. So this is like by changing the resistance. So this is a resistive potentiometric transducer. I hope it's clear. And also we discussed about Wheatstone bridge, right? So how the Wheatstone bridge like this one. So if you want to operate this one, we need external electrical supply, right? So that's why these type of transducer require external electrical supply. Here also we require external electric supply if you want to operate your Wheatstone bridge. So here are deflection plate, deflection meter, and R1, R2, R3, R4. Alright. So when the bridge balance R1, R3 is equal to R2, R4, then only the bridge will balance, right? At this condition, it will reach null deflection. So what is the voltage across this galvanometric deflection is 0 volts. For suppose if you want to find the temperature, right, directly you apply whatever the change in temperature here. If you apply a change in temperature, resistance will vary. So this phenomenon got worst, right? Right. So R1, R2, R1, R3 not equal to R2, R4, right? By changing the temperature, your resistance will change. Whenever the resistance will change, the galvanometric deflection moves not the 0 value. If it moves 2 volts, how you are getting the 2 volts means by changing the temperature, you are getting your voltage is 2 volts, right? It means whatever the change in temperature, which is a non-electrical quantity, so that equivalent electrical quantity 2 volts. So you are converting your non-electrical quantity into electrical quantity, so then we can call it as a transducer by changing the resistance. Due to the change in resistance, your voltage will be changing, right? So these type of transducer we can measure the temperature with the help of Wheatstone bridge type, right? So these are the things that we discussed in a last session, right? I hope it's clear what is I hope you got an idea, right, what is a resistive transducer, right? Now we'll discuss one of the most important concept in resistive transducer. Definitely you'll get a question, a resistive thermometer. In this session we will discuss about resistive thermometer, resistive temperature detector, we can also call it RTD, and what is the advantages of resistive transducer, and what are the disadvantages of resistive transducer, and what are the applications, right? So with that we will conclude this resistive transducer. Then we'll discuss about inductive and capacitive transducer, right? Now I'm going to start. The concept is another example for resistive transducer. Definitely will get a question. Very, very important. So resistive thermometer. Resistive thermometer. So we can also call it as resistive temperature detector. We can also call it as RTD. Right? So we can also call it as resistive temperature detector, and we can also call it as RTD. Right? It is a resistive transducer. The name itself indicates it is a resistive transducer. we will discuss about the principle. So what is the principle? So what is the principle? You find the change in temperature. If you want to find the temperature by changing the resistance of the metal, right? Similarly, the each and every resistive transducer will work. Change in the resistance. Right? So what is the principle? If you want to find the temperature in the metal, so how you can find the temperature? By changing the resistance, by measuring the changing resistance in the metal. So you will directly find your temperature, right? You know, in a room temperature, right, body temperature, we have a thermometer. So with the help of these thermometer, you can easily find out your temperature. But what about the metals? So it's very difficult. You don't have any direct device to find out the temperature in a metal. How much a temperature rise in a metal? It's very difficult. So for these type of things, we just go for a resistive thermometer to find the temperature, change in temperature by measuring the changing resistance in the metal. Right. So this way, in this process, right? So in this process, first we should know what is the relationship between the resistance and temperature, right? If you vary the temperature, your resistance will be vary. So if you want to measure that resistance, whatever the resistance, that is analogous to the change in temperature, right? So this is the principle. It's very simple. Resistive thermometer is nothing but we can call it as a resistive temperature detector. We can also call it as RTD. So it's one type of resistive transducer. So what is the principle? You can find your temperature by changing the resistance, by measuring the changing resistance in the metal itself, right? That means you don't have any direct measurement for the metal temperature, right? Body temperature, room temperature, you have a devices like thermometers, right? Mercury thermometer for change in room temperature that we discussed earlier, right? We don't have a direct method to find the temperature in the metal itself, right? So for this we use these type of resistive thermometer. Right. So before going to this, you have to know what is a relationship between the resistance and the temperature. Right. So you know that the current is nothing but flow of electrons now. Flow of electrons. Right. So I is inversely proportional to resistance. If resistance increases, your current is going to be reduces. Right. You have a metal. So when you heat it up, right, when you heat it, that means you are giving thermal energy, right? When heat it up, what about the flow of electrons will be very high now, right? So flow of electrons will be very high means your current is going to be increases now. So what about the resistance? Resistance is going to be reduces. So main concept of temperature, if you increases the temperature, the current will be increases, thereby the resistance will be reduces. So whatever the temperature or resistance which are or is inversely proportional to temperature. So if you increases the temperature, your resistance is going to be, if you increases the temperature, your resistance is going to be reduces. So this is, we can call it as a negative temperature coefficient. Right. So basically the relationship between the resistance temperature means if you increases the temperature, your current will be increases. If the current is increases means your temperature is going to be, your current is increases means your resistance is going to be reduces. That means you are increasing your temperature, your resistance is going to be reduced. So this type of thing we can call it as a negative temperature coefficient, negative temperature system. This is a negative temperature system, right? Or else in some of the things that we have a positive temperature coefficients also. That means if you increases the resistance, your temperature also increases, right? Right. So this is the relationship between the temperature and the resistance, right? And what is a basic relationship means R is equal to R naught into 1 plus alpha 1 T1 plus alpha 2 T2 square plus alpha 3 T3 square and so on. So this is a basic relationship between the resistance and the temperature. Got it now? Alright, where R is nothing but change in resistance, right? R naught is nothing but resistance at 0 degree Kelvin. 0 degree Kelvin. So alpha 1, alpha 2, these are constant, right? So T1 is nothing but temperature at T1 degree Kelvin. T2 is nothing but temperature at T2 degree Kelvin and all these things. So this is the basic relationship between the temperature and the resistance, right? Now, so up to now what we discussed, the resistance thermometer, right? So we can call it as a resistive temperature detector. So we can also call it as RTD. It's a resistive passive. It's a passive transducer in that it is a resistive type transducer, right? So what is the principle of operation? You can find your temperature by measuring the changing resistance in the metal, right? So we don't have any direct methods to find the temperature across the metal. So if you have a body temperature, room temperature, you have a devices, right? So first you should know what is the relationship between the resistance and the temperature. If the temperature increases, the flow of current will be increases. If the flow of current is increases, means the resistance will be reduces. That means if you are increasing our temperature, you are reducing our resistance. So this we can call it as a negative temperature region. We also metals that is having a positive temperature region also. So basically the relationship between the resistance and temperature is equal to R is equal to R naught into 1 plus alpha 1 T1, alpha 2 T2, alpha 3 T3 square and so on. Right. So where R is nothing but resistance, R naught is resistance at 0 degree Kelvin, or alpha 1, alpha 2 is the constant, T1 is the temperature at T1 degree Kelvin, T2 is the temperature at T2 degree Kelvin. Right. So this is the thing. Right. Now we'll discuss about metals. So you use the metal. So where you are finding your temperature in the metals, what type of metals that you are going to use. Right. So basically we are going to use the metal called platinum. So in order to find the change in temperature, in order to find the temperature with the help of these resistive temperature detector, you can use the metal called platinum, right? So which is having high temperature withstand. High temperature withstand. It also more stable. Right, whatever the temperature, if you increase this temperature, the metal can withstand. So the stability of the metal should be very high. It doesn't have any contamination. Right, it doesn't have any impurity contamination. Right. So basically, in these type of RTD, we are going to use a metal, not semiconductors. Right. So the metal which is having positive temperature coefficient. Always we go for a metal, not the metal conductors only, not the semiconductors, because the semiconductors which is having negative temperature coefficient, right? If it is a negative temperature coefficient, if you are increasing your temperature, your resistance is going to be reduces. If the resistance is reduces, it's very difficult to find out the change in resistance. With the help of the resistance is reduces. See, one more time, always we prefer a metal conductors, not for the semiconductor materials. Why? Because not semiconductor materials use చేయమంటే it is a negative temperature coefficient. So that means if you are increasing your temperature, resistance will be reduces. So its resistance will be reduces, the output electrical quantity it's not that much effective. Right? So that's why we are going to use a metal conductors, so which is having a positive temperature coefficient. So what is a positive temperature coefficient? If a temperature is increases, your resistance also going to increases. If the resistance increases, it's very easy to find out the change in resistance with the help of voltmeter. You can convert the change in resistance into electrical that can be useful for. Got it now? So what type of a metal that can used? You can use a metal called a platinum. Right? Why the platinum means which is having high temperature withstand, stable condition, and it doesn't have any impurity contamination in that materials. Right? So always we prefer a metal conductor, and we don't use for semiconductor materials. Why? Because semiconductor materials is a negative temperature coefficient. That's it. Right? Now the construction of a RTD. Right. So this is a simple construction of RTD, which is a metal leads, so metal layer. So this is called a sheath. So this is called a protector. Right? So this is called a metal leads. So metal leads, and this is called metal layer, and this is called a sheath, and metal. This is called a protector, right? So where this is called a element. Right? This is called element. So whatever the elements that metal, that is a platinum metal that can be used here. So this is a simple construction of a RTD. Very, very important concept. So what is a simple construction of a RTD? Right? Right? So whenever you apply your temperature by heating these leads, right? ఎప్పుడైతే దీన్ని whatever the temperature that you require, you need to heat these leads. ఎప్పుడైతే హీట్ చేస్తావో, whatever the platinum which is having a positive temperature coefficient. So whenever the heated these leads, the resistance of platinum material will get changed. So the change in resistance you can find out by with the help of voltmeter and all these things. So that means whatever the change in resistance, which is analogous to change in resistance. And if there is a change in resistance, you can easily find out the change in resistance into electrical energy. Right? So whatever the non-electrical quantity is a temperature which is converted to electrical quantity, voltage. Right? So what happened? Temperature leads ni heat చేస్తావు. So what happened? The metal which is having a platinum, which is having a positive temperature coefficients, ఏమవుతుంది? సో ఎప్పుడైతే హీట్ వస్తుందో, టెంపరేచర్ని ఇంక్రీజ్ చేస్తావో, the resistance of the platinum metal will get changed. So you will get the change in resistance. So that means whatever the temperature increases, that is nothing but the changing resistance. The passive transducer occurs, right? You can easily find out the changing resistance with the help of voltmeter and all these things. That means whatever the temperature changes, which is equal to the voltage. So this type of transducer is nothing but a resistive temperature detector, right? So I hope it clear. So the construction is that much. Construction is important, and what is the working principle? So what is the working principle? The temperature you can find out by measuring the changing the resistance in the metal itself. So that is a function of a RTD, right? Now basically we go for a metals called silver, copper also, right? So not only platinum, which is a very costly metal, so right, that's why we go for a metals called silver, copper, nickel, right? Gold also, we can go for a gold also, right, which is having low resistivity, right? So these are the metals that we require for using in a RTD, right? I hope it's clear, right? Now we'll go for what are the properties of the metals, right? Whatever the metal that you are using in RTD is very very important, right? The properties of the metals used in RTD. The first property, right? So these type of metal, the smallest change in the temperature, the largest variation in the resistance, right? The smallest change in the resistance temperature, the largest changes in resistance, right? Small change in the temperature, the largest change in the resistance. So those type of metals that are going to choose, right? So the metals which is having high resistivity, right? So the metals which is having high resistivity, so then only the size will be very small. So that means, why means the size will be small, because the resistive temperature detector is very small in construction. So whatever the metal that are using in a resistive temperature transducer, which should be very small. So that means the metal which is having high resistivity, the size of a platinum materials is a very small, right? One more thing, it can withstand high temperature also. High temperature also, right? So whatever, if you are increasing the temperature, if a metal conductor which you are using, if it is a melt, there is no use. So that means these are the main properties of a metals while choosing in RTD. So what is the property? The smallest change in the temperature, the resistance will be increases enormously, then only you will get proper output, proper electrical output, right? The metal which is having high resistivity, right? High resistivity means the size of the metal should be very small. So those type of metals that you are going to choose while functioning your system, right? And it can withstand high temperature. If a temperature increases, if a metal gets melt, so no use in case of RTD. So we require the metals with high temperature coefficient. So these are the properties of our metals that used. So what are the metals that used? Basically we are going to use a platinum metal, platinum, so which is a high temperature coefficient, stability, non-contamination, right? And basically we could go for a silver, nickel, gold also, use these type of metals also. But if you use these type of metals, how the temperature and resistive graph will be? If it is a temperature and resistance, the graph will be it like a copper, it's a gold, it a platinum, right? You will see how the temperature and resistance. So this curve is a non-linear curve, and for a copper it is a non-linear curve, for gold is a non-linear curve. So the platinum which you are getting a linear curve. So that means if you use these type of platinum, it will be very helpful, very useful for finding the correct measurement of a temperature. So that's why we require a platinum material. So we'll go for copper, gold, nickel and all these things. So it will be very useful also if the platinum cost is very high now. So that's why we just go with the copper, silver materials also. Right, this is about RTD, resistive temperature detector. I'll explain one more time. A very very important concept. So what resistive thermometer? So we can also call resistive temperature detector, right? So we can also call resistive temperature detector. It can be denoted by RTD. It is like a passive transducer, right? It is like a passive transducer. In that it will act as a resistive transducer. So what is the principle of operation? In order to find the temperature, so whatever you need to measure the change in resistance in the metals, right? That is the principle of operation. Nothing, the physical quantity. So it is a resistive transducer means what is the physical quantity? The resistance will be changes in order to find your non-electrical quantity. Alright. So what is a first you should know the relationship between the resistance and temperature, right? Current is nothing but flow of electrons. If you increases the temperature, the flow of electrons will be increases. If the current is increases, what about the resistance? Resistance is going to be reduces. So the temperature is inversely proportional to the resistance. So that means these are a negative temperature coefficient. We have a positive temperature coefficients also. We can use this one. So actually what is the relationship between the resistance and the temperature means R is equal to R naught into 1 plus alpha 1T, like this. So where R is nothing but change in resistance, R naught is nothing but resistance at 0 degree Kelvin at different temperatures, like this. Now what are the metals that you are going to use? So basically we are using the platinum metals. Why? Because which is having a high mechanicals, high electrical strength. That means temperature withstand, stable condition, non-contamination of impurities, right? So we always go for a metal conductors. The metals that we are using in RTD is a metal conductor, not go for a semiconductor. Why? Because in a semiconductor the temperature what is in a semiconductor, which is a negative temperature coefficient. For in the case of metal conductor, which is a positive temperature coefficient. So why metal conductor means positive temperature coefficient means where temperature increases, your resistance is going to be increases. If your resistance is increases, you can easily find the whatever the electricity that you are coming out from the changing resistance. It will be helpful for other instruments. But if you use a semiconductor materials, whatever the changing resistance will be not that much great. So the voltage will be not that much clear. So that's why we go for positive temperature coefficient, right? Now the construction is like this. ఎప్పుడైతే ఇక్కడ మెటల్ లీడ్స్ ని హీట్ చేస్తావో the temperature, if you want to find this temperature, so accordingly your metal resistance, the platinum metal resistance will be changed. You will find the change in resistance. So whatever the change in resistance which is equal to applied temperature, change in temperature here. So you can easily find the change in resistance voltage, whatever the temperature which is equal to the voltage across the change in resistance. So that is a construction principle, right? Whatever the materials that we are using in so the properties of a materials, right? So what are the properties of a materials? The materials which is having a high temperature coefficient, the smallest change in the temperature, the resistance should be very high. Those type of materials that you are going to choose while calculating, right? And after that the metal which is having a high resistivity, then only the size of the metal should be very high. It's very small, right? So what are the metals? You can go for a copper, silver, gold, nickel. Those type of materials also used, but the temperature and resistance characteristics are a non-linear characteristics they are getting. So these are the disadvantages while using. Now we'll go for advantages and disadvantages of a resistive transducer. So advantages of resistive transducer. Right? It will give quick result. Right? So what are the best advantages? It will give a quick result. And the second one is it requires in a small size. Right? The size of the resistive transducers is very small. Right? So it can also used wherever not necessary in a circuit, right? These type of transducer, if you won't require also, you can use these type of transducer in our circuit because for resistance variations, right? And it will give an accurate result, right? The cost of these type of resistive transducer is very less. Right. So these are the advantages of resistive transducer. So what are the advantages? Quick results. You will get the quick results, accurate results, and these are available in a small size. Right. Highest resistance also, you are getting high resistance materials also available. Right. For this, we can usually find whatever the temperature, whatever the displacement it is, and all these things. Right. What are the advantages of resistive transducer? These are quick result. It's a small in size. Whatever it can be also used where when the circuit is not required. This type of resistant transducer also accurate results. Cost is going to be very less. So the size that means the high resistance materials also we require in our daily life, right? And what are the disadvantages? Right. So lots of power. It will take lots of power while moving your sliding contacts, right? Lots of power required. Right. While moving sliding, right, potentiometer sliding means lots of power is going to be wasted. Lots of power is required to move that sliding contacts, right? And the second one is noise. So while moving these resistive type transducer, there will be some noise will be present in the system. So these are the disadvantages. What are the advantages and disadvantages? Means quick result, accurate result, small size, and high resistive materials also available. It can be used wherever not necessary in the circuit also. Right, small size, cost will be very less. And what are the disadvantages? Means it will require high power to move the sliding wire, and also will get some noise, right? And applications, you know the applications, right? You know the application by displacement calculation, right? By pressure calculations, by temperature calculations, right? Strain calculations, right? Resistivity calculations, all these things. These are the applications of a resistive transducer. So what are the you know the displacement? If you change the displacement, the resistance will be changed. Pressure, if you apply a strain, your displacement will change. LVDT we'll discuss in further sessions, right? You can find the temperature. If you increases the temperature, resistance will be changed, right? You can apply the strain, your resistance will be changed, right? Right. These are the applications that that you can use to with the help of these resistive transducer. Right. So till now it's enough. In the next session we'll discuss about inductive transducer. So what we discussed in the session: what is RTD, what is the operation and principle, what is the construction, what are the metals, the properties of a metals, and some graphs. After that, advantages of resistive transducer, disadvantages of resistive transducer, and application of resistive transducer. So with that, with this we completed the resistive transducer concept. In the next session we discussed about inductive transducer. Right. Thank you for now.